Hello, geometry scholars. Today we are going to discuss trapezoids and kites. And just to kind of give you an idea of a roadmap here, the first shape that we studied in this unit were just the plain old four-side quadrilaterals. And last time, Miss Adkin presented on the parallelograms, which have two parallel sides. And what we are going to do today is we are going to discuss the trapezoids that have only one parallel side. So I'm just going to draw a picture here. So we have one parallel side for trapezoids. And then there's a special type of trapezoid that is called the isosceles trapezoid. And what that has in terms of features, so both the legs are congruent, the base angles are congruent. So like angles that share the top side, the bottom side, and you still have your one pair of parallel sides. And then on the other part of the family tree, we have what is called a kite, just like maybe what you've flown in the park in the past, and it is actually shaped like that. So some of its features include the 90-degree angle that it intersects at. One of my students a few years ago, he actually called that like a make Jesus property because it does kind of look a little bit like that type of cross. And then the sides that are next to each other are congruent, and there are one pair of opposite angles with those. So I would really encourage you to actually go and mark in the congruent sides and the congruent angles for those. All right, so here we're just going to talk about like the non-isosceles trapezoids. So this is the property of all trapezoids, including isosceles. So we'll just kind of put all trapezoids here. So parallel sides are called bases. And I'm going to, and there's only one pair of parallel sides. So I would encourage you to mark a picture. So these are the bases. And then the non-parallel sides are called the legs. So that's a leg, and that's a leg. And then these angles are called like base angles when they share the same base. And a fourth property is that the same side angles, or same side interior angles, add to 180. So for example here, what we'll kind of do, if this is 120 and this is x, we could then say that 120 plus x equals to 180, making x 60 degrees. So that is the some of the things and features of all trapezoids. Now, we like to focus a lot on the major isosceles trapezoids. And what's nice about those is that they are kind of symmetrical. So I always advise my students to use symmetry. So one property is that the base angles are congruent. So what I mean by that is that angle A is congruent to angle D, and angle B is congruent to angle C. And you can actually kind of see that the isosceles trapezoid is nice and symmetrical, and I just drew kind of that dotted line to show you that it is. All right, then we also have that the legs are congruent to each other. This is kind of a defining feature of an isosceles trapezoid. So what I mean by that is that AB, side AB, is congruent to side CD. So, like if AB was 6, then this was X, you could immediately read and say that that is 6. So, for isosceles, I always like to say, think symmetry. And then the diagonals are congruent. They don't bisect each other, but they are congruent to each other. So what that means really is going from D to B is the same thing as going from, let's get another color here, it's the same thing as going from A to C. So that red line and that blue line are matching up with each other and are congruent to each other. All right, and then there's another theorem. This is called the mid-segment theorem of a trapezoid. So in a nutshell, what this means, let's say that I have a trapezoid here that is isosceles. Actually, it could even be like a non-isosceles, but they have to kind of have a line here that divides each leg into half. So this has to be congruent to that piece, and then this piece has to be congruent to this piece. So let's say that this is 8, and this is 12. So to get the mid-segment, what you would do is you would do 8 plus 12 divided by 2. So you would get 20 divided by 2, which is equal to 10. So in other words, 10 is the mid-segment, and that's halfway between 8 and 12. So that is another useful theorem. The technical piece is on the PowerPoint here, and I would encourage you and even require that you copy that theorem down as well in your notes. No need here to worry about the theorem number, but just know that this is called the mid-segment theorem. All right, so now here are some kite theorems and properties that are useful to each other. So one is that the diagonals are perpendicular. Meaning that they intersect at 90 degrees. So this is the property that my student called a few years ago, make Jesus, because they do form 90 degrees. Likewise, another useful property is that there are one pair of opposite congruent angles. So like if this angle was 110, then that angle would also have to be 110 degrees. And then kind of by definition of a kite, you know, if this side was 5, this side would also have to be 5. And if this side was 7, then that side would also have to be 7. So the sides that are adjacent to each other are congruent to each other as well. All right, this is your typical Pythagorean theorem problem here with a kite. So what we have here are right triangles. So don't think of this as a kite problem, but think of this as a right triangle problem instead. Also, I encourage you to be thinking about how the kite is symmetrical as well. So if this side is 3, this side is 3. So if I want to actually solve for x in this triangle, since I have a right triangle, Pythagorean theorem works. So I would do 3 squared plus 4 squared equals to x squared. And I just square root. All right, so then I'm just going to square root my 25. So I get that x is equal to the square root of 25, making x equal to 5. Now, since x is equal to 5 and the kite is nice and symmetrical, then I can also reasonably say that that side is 5. And then for this side, you want to focus on the right triangle. So I'm going to do 3 squared plus 8 squared equals to y squared. So I get 9 plus 64 equals to y squared. So that's 73. And I could say that y is equal to square root of 73. You are free to change to decimals if you want to. Or you could keep it in radical as long as it does not say, you know, simplified radical form. All right, and then this is your classic kite angle problem here. I think you should really take advantage of the symmetry of the kite. So I even like to kind of draw that line of symmetry in there. Right there. If this is, we don't know what this angle is, so I'm going to call it x. And then the angle down here also has to be x, since that kite is nice and symmetrical. And then we know that the 4 angles of any quadrilateral add up to 360 degrees. So that's going to be 192 plus 2x equals to 360. And just subtract the 192 from both sides. And you're going to get 168. So therefore x would be 76 because we divided both sides by 2. So there are a lot of properties with trapezoids and kites. So the main thing that you do want to do, you know, think symmetry. Also think about the properties as well. Those properties are kind of a roadmap as to how to solve the problems.